Good morning, everyone. So first, I hope we're all well. And for those in the UK, I hope we are planning to make our last-ditch attempts at getting some food and going to some non-essential shops before we can't do that on Thursday. But I do hope that everyone is well. So my name is Will Yates. I'm the CICS test architect, and I'm also one of the leads of the Galassa project, where we're creating an open source test integration framework. And what we're going to be doing in this session is talking about not just CICS's strategy, but the IBM cloud strategy and how CICS is going to remain relevant and a vital part of that strategy in the years to come. And we're going to be talking about CICS's relevancy into this chapter 2 of the journey to cloud. Now, you'll have heard Arvind and Ginny talk about this chapter 2 of the journey to cloud, and we're going to be kind of trying to discuss what implications that has on CICS as we look forward to the rest of this journey to cloud. So we know full well that cloud is a good thing, that cloud and being able to access infrastructure, capabilities, APIs and services as a service from a cloud provider is pretty much uniformly a good thing. It allows you to accelerate your digital transformation by making use of new applications, new assets really quite easily. So a good example for this is we built a good few years ago a POC where we had a Alexa device, and I'm sorry if I've just set off Alexas in all of your homes, but I'll do it again, an Alexa device. And we allowed that to drive a CICS transaction to understand someone's bank balance. Now, as part of that, we needed to do an element of natural language processing. Now, as good as my COBOL is, I don't think I was necessarily up to writing natural language processing algorithms in COBOL. So instead of writing that myself, I used an API that was available on the IBM cloud. I used Watson natural language processing to be able to take the string of characters I've been sent from the user and turn that into a sequence of intents and nouns that I could then understand what the user was trying to do. So using the cloud to accelerate your digital transformation and allow you to fully adopt all these new APIs allows you to create great new digital experiences for your clients. But as we look across the entire enterprise, we only see that only 20% of those workloads have actually moved to the cloud. So why is that? What is stopping the other 80%? And it's this 80% that we're calling the second chapter of the journey to cloud. The first chapter was moving that first 20%, that easier set of applications across to the cloud. What about chapter 2 and the remaining 80%? Well, there are three main reasons why it is preventing those applications or those workloads from moving to the cloud. The first is obviously this 80% will probably have some sort of unique workload or data needs. That may be a compliance need, a security need, a GDPR location need, and that the data needs to reside in a certain geographical location. But it could also be that the amount of data is just so large that there isn't an adequate cloud technology to allow you to handle that data. We've seen clients with incredibly large amounts of data, knowing that if they tried to move it to cloud, they'd end up having to shard that data, which means splitting it up into smaller pieces and scattering it across a set of nodes. And for a lot of people, the risk of doing that was just too great, when actually you can get the throughput you need by just hosting that data on the mainframe with its great I/O capabilities. The second is that very few users or very few businesses are planning to use just a single cloud provider or a single vendor. They're actually going to be connecting multiple clouds and multiple vendors. And when you start to consider that I've now got multiple clouds that are hosting parts of my application, and they all need to connect to a single maybe CICS application, I've now got multiple routes into my application that I need to consider. I need to make sure that I can apply the same security across all of those entry points into my application. There's also a technology generational gap. We can experience this in Hersley. We have new people coming into our team, and we talk to them about our DevOps processes and the way that we roll out applications and we test applications. And those guys talk, as we call it cloud native. They can speak cloud native. They understand what a container is, what an image is, what a pod is, what a persistent volume claim is. And they can talk about those things very, very well. But then we start talking to them about things like LPARs and address spaces and CICS regions, and they've not been taught that language or taught those terms, so they don't understand what they mean. And maybe for some of us, we don't necessarily speak as cloud native as we'd want to. And so often there becomes a mismatch between expectations and the way that people are discussing. A lot of the time, the actual concepts that people are discussing are roughly the same. Things like transactional integrity, security, they're the same base principles, but they're just implemented differently and they bring different language. And that can cause a problem as people find it difficult to communicate to the other group of people, and we end up in these almost turf wars. And having those turf wars not only makes a particular platform look bad, but it also doesn't help the idea of trying to integrate these platforms together. As we kind of discussed on the previous chart, no one is using a single cloud, or very few people, I should say, are using a single cloud provider. They're picking whichever cloud provider makes sense for each particular piece of work they need or particular service they need to obtain. In fact, 94% of the enterprise users that were interviewed said that they're using multiple clouds. And 67% are saying that it's more than one public cloud provider. So they're not putting all their eggs into a single public cloud provider. They're being spread who provides the best capabilities for the workload that needs to be run. And 81% of people are using a combination of private and public clouds. So this is just adding to the problems that we discussed previously. We've now got a multiple or more than one public cloud, and we've also got internal on-premise private clouds as well. And handling all of those applications in a consistent, manageable way is going to become a new reality for a lot of these people. How do I understand exactly where all of my application sits, and regardless of which cloud provider it's running on, how do I control it, secure it, audit it as a single end-to-end application? And of course, considering this is GSE, the mainframe and the applications that run on the mainframe, and in particular for this track, the CICS applications, are going to be part of that puzzle as well. And ensuring that the CICS applications that you're currently getting incredible value from maintain that value in this hybrid multi-cloud reality is exactly what this session is going to be focusing on. And from IBM's perspective, there are 5 key principles that define our approach. And the key one perhaps is it's hybrid. There is not going to be a reality where everyone is using one cloud provider. The stats are very clear. People are going to be using multiple cloud providers and private clouds within the same application. So therefore, our approach needs to encompass that and ensure that regardless of the cloud provider that you're using, IBM products, IBM capabilities can be used across all of those platforms. It's also going to be multi-cloud. Not only are we going to be looking at clouds both in the public domain, but also on-prem private clouds. They're going to be other people's clouds, other vendors' clouds at the same time. Our approach needs to be open, avoiding vendor lock-in, allowing you to build capabilities and use our capabilities that are open by design. So that's having open protocols, open software, and in a lot of cases, open source software that can be extended and used by others. Obviously, the mainframe is known for its security, and that security needs to be part of our approach as well, ensuring that you can secure the end-to-end application regardless of the hybrid or multi-cloud platforms that the application is running across. And management. Wherever this application is sitting, you need to be able to have a consistent way of servicing the application, supporting, logging things that are going on with that application, and deploying new parts of the application to that platform. So this is the 5 principles to IBM's approach to the hybrid multi-cloud world. But what does that mean to Z? How do we allow the applications that we've got in Z to really take advantage of this approach and integrate in a first-class way with this multi-cloud reality? And there's 3 options. First one is keep the status quo, just keep the lights on, keep things working. And not making any radical or changes or any kind of redevelopment efforts to those applications, just keeping up with the status quo. Well, we've seen this with clients that we've spoken to who have tried to replace certain parts of their application from the mainframe and run it purely on cloud. And while that very expensive, very long process was running, they just kept the lights on with the mainframe, just did the bare minimum to keep the business ticking over. And in quite a few cases, that attempt to migrate the application off of the mainframe onto a completely 100% cloud provided application failed. And then the company now was in a very poor place. Not only had they spent a lot of money on an exercise that had ultimately failed, but also they now had a state where their applications that were sat on the mainframe, where they'd spent so long just ticking over, hadn't been modernized, hadn't been enabled to support things that would allow that company to create great new digital experiences for their clients and thus win market share, which meant that actually they saw customers leaving their platform and leaving their business and going to somewhere else because they could get a better experience elsewhere. In times where, especially that we find ourselves in now, where customers really are doing so much more digitally, it's vitally important that we can provide the best experiences, because often their decision will be based on the applications that they have available to them, usually on their phone. So the second option, well, we'll re-architect the entire infrastructure and we'll move pretty much everything that we've got straight over to cloud. Well, I think we can pretty much confirm that's a very high risk option to take. Will it all work? Will it still have the same service level agreements when it's running on cloud? How much would it actually cost over there? And what do we gain from doing so? What is the reward from doing so? When actually we've got something that works here, what is the reward if we just move it to a different platform? What is the intrinsic benefit of moving it to that platform? And this is where option 3 kind of comes in to kind of provide the best of both worlds. If you've got assets on IBM Z, you can modernize and leverage those assets to accelerate your digital transformation. And that often means integrating them into a hybrid cloud architecture. So taking the applications you've already got and getting more value out of them by allowing the rest of the enterprise to integrate with them. And when we look at the types of applications that we may want to apply this option to, we see that at least half of the applications, we could modernize and migrate to cloud. And we could take those applications and we can modernize them often in place, perhaps changing language, using the latest DevOps pipeline technologies and tools to allow us to take parts of the application, add new capabilities to them, maybe collapse 2 tiers down into one, and allow you to provide greater capability within your existing CICS outlay. The rest of the applications that we may have, there are going to be a small percentage of the applications where actually you would rationalize and you decommission that application. It's no longer required. Maybe it has a very, very small usage. It's no longer required. It could just be got rid of. There may be an even smaller percentage of applications where you do decide to replace them with a as a service. There's something you can now purchase off the shelf from a cloud provider that would do that same job. And there may be a smaller, around a fifth of your applications that you do just need to retain and keep ticking over. But as I say, half of the applications we think could be used to be modernized, to allow them to be called from a cloud application and basically give you greater value. So there's three stories that we want to discuss on how CICS and how CICS applications are really going to be leveraged within a hybrid cloud world. And we're going to spend a little time talking about numbers 1 and 3, but we're going to really focus on 2, because that's really where the heart of the work we've done in CICS version 5 and in CICS version 5.6 that will allow you to gain the most value. But we're going to take them in order, but we will be focusing most on option 2. So the first one, we're going to be talking about APIs and API economies, and how utilizing APIs or allowing your applications and your assets to be exposed as really high quality, high fidelity RESTful APIs will allow you to unlock extra value from these applications. Now, unlocking value through APIs, this whole kind of concept isn't particularly new. I started back in CICS quite a few years ago now. And when I started, my first role was to do some of the testing on CICS web services. And CICS web services, the whole idea behind using service orientation architecture and web services, so just SOAP over XML, was to allow your CICS applications, your traditional applications, to be exposed to the rest of the enterprise, maybe through an enterprise service bus, to allow them to be interacted with by new consumers and other parts of the business. And unlocking value through APIs and using the API economy is the same idea, but to use a music analogy, it's kind of turned up to 11. Because with APIs, your customer, your client, the person that's going to be using the API is no longer just another part of the enterprise, another machine. Often it's going to be a developer that is going to be writing code that's going to interact with the APIs. Thus, it's more important than ever that those APIs are delightful, that they're easy to use. Because if I'm a developer and I'm writing some code, I'm creating a new digital experience for my client base, and I need to use some APIs, that my desire to want to work with them is going to really depend on how easy and useful those APIs are to use. And as an API developer, I'm probably not going to be too familiar with a lot of mainframe technology. And this is the point that we were making about this age gap or technological age gap between the people that are perhaps very familiar with working on Z and these newer developers that are coming into our enterprises. If I expose something to a developer, maybe a RESP code or a RESP2 code, that API developer may not have a clue what that is. He's not going to understand that he can take that value and compare it with DFH RESP normal, and he'll be able to understand what that is. He wants to perhaps get his error codes in a slightly different way. So it's important that when we create these APIs and we expose them in a catalog to an API developer, that we make them, we have them fit that client in the same way that when you're writing a book, you understand your audience, you use language that is specific to that audience. It's important that we do the same with APIs. We understand who our developer is, what they need, and we provide them just that right information. So from a Z perspective, allowing you to create a set of APIs that expose your traditional applications in a way that is easily consumable by an API developer is vital to allowing these applications to get maximum reuse and unlocking their extra value. Now, I think it'll be unsurprising when you see this slide that I'm going to spend a couple of minutes talking about ZOS Connect, because ZOS Connect is a mechanism for exposing these applications to your front-end application. And it's not just for CICS. As we know, it's for CICS, it's for IMS, for DB2, batch, it's for a whole wealth of things. But it allows you to generate an API that you can then expose to a front-end or another business application. And doing so is has quite a few positive advantages. It requires no change to your existing backends in most cases. Now, obviously, if you've got an application which is very highly integrated, your business logic and your presentation logic are very intermingled, then there may be some code changes involved, but those code changes are going to be advantageous in other ways as well. But in the case where the presentation logic and your business logic are well separated, then really there should be minimal changes to your existing backend application. And the other positive is that it's going to unlock that application for lots of other uses. And this positive is something that isn't just unique to APIs. It's been familiar to service-oriented architecture and web services as well. But the downside is that you are treating the ZOS application pretty much as a black box. Because it's unchanged, you're just putting a new front end on it and hoping that the back end still works. What happens when you do need to make a change to that back end application, when you do need to update it or add new capabilities to it? So there are a whole wealth of tools that will allow you to understand what APIs you can expose, how you can expose them, and then effectively build the application and to expose the API and then manage it with an API management tool. And this comes back down to our principle around things being open. This stack of products you see here from ADDI, CICS, ZOS Connect, API Connect, Splunk, IBM Common Data Provider, although that is an IBM stack, all of the technologies within there are fundamentally open. So if you look at the APIs that we produce with ZOS Connect, they are industry standard JSON APIs. So if you want to manage them with a different API management tool, you can. That's your choice. Using one of these products doesn't necessarily lock you in to using all of the rest of them because of that open principle. We are integrating with other vendor products. We're allowing you to choose your implementation solution, but these are the products that we would offer. The second story, and where I said we're going to spend the majority of our time, is talking about modernizing your applications in place. Because we truly do believe that the enhancements and the capabilities that we've introduced, not just in CICS 5.6, but in the whole of the CICS version 5 story, allow you to do this with greater flexibility and greater capability than ever before. Version 5, across all of the releases in version 5, really has been an evolution of our capability in application hosting. You may have heard us talk before across the version 5 timeline as presenting CICS as the world's premier multi-language application server. That's really been our kind of key drive throughout the whole of the version 5 timeframe, to allow you to host applications written in multiple languages, but provide those mixed language applications with the same qualities of service, the same capabilities, and CICS services that you've come to know, understand, and expect. So I did some work a couple of months ago. I think it was back in February, just before in the UK we received our go home and stay at home orders. In that time, we produced a COBOL education course with the Open Mainframe project. And it's a piece of work I'm really proud of, because we were able to, with a global group of people from both academia, IBM, and vendors, generate a course to teach the next generation COBOL. Give them enough COBOL to be dangerous. Give them enough COBOL to look at something and not go, ugh, what's that? I don't like that. It's got no semicolons at the end of lines. I don't understand it. It's all uppercase. Ugh. To actually give them enough so they could look at a COBOL application and get a feel for what that application is doing. And we made that course freely available. But although these people, these new starters may now have some education in COBOL, their primary language probably won't be COBOL. It's definitely not taught massively at universities, at least in the UK. They're going to be more aware of other languages, such as Java, such as Node.js. And you may want to say, well, what parts of our application could we migrate to use not a better language? It's going into GSE UK saying what's a better language than COBOL is perhaps not the best thing I've ever said, but a different language, maybe one that we can support more easily in our organization. And then when we've taken that application and we've rewritten it into a different language, hosting it back onto ZOS. Now, this may not be just taking a whole application. As I said, CICS is the premier mixed language application server. You could just take a component of an application, even a shared component, take that component, rewrite it in a different language, and rehost it back onto the platform. And in doing so, we've introduced a whole range of cloud-native DevOps tooling, CI, continuous integration, continuous deployment, tools, technologies to allow you to do that refactoring in a cloud-native style, in a style that these newer developers may be able to understand a lot more easily than some of the practices we already have. So the net of this is it allows your enterprise applications teams to look at the range of applications that are running on CICS and say, well, which one of these could we update? Could we move to a different language to help us to support it in the long term, to give us a bigger pool of developers that can work on the application? And how can we redeploy that application using the latest CI, CD, DevOps tooling and technologies to ensure that we have the quality right when we deploy it, that we have all the checks and balances have been made, that we understand that this new component is now ready for production deployment into a production environment. So this is just a picture of the kind of things I was just talking about, where we could take a portion of a COBOL, CICS, or IMS application, we can rewrite it, refactor it in Java, and honestly, the things that we've done in version 5.6, and in most cases we've backported into older versions of V5, really make this a joy to use. If you've done some Java programming in CICS before, and you've not looked at the JKIXX stuff that we've done, your mind is going to be blown. This stuff really is great fun to work with. But take that application, take a component of it, rewrite it, refactor it into Java or into Node.js, and then place it back onto ZOS. And while you're doing that placing back onto ZOS, you're going through that iterational loop. You're planning it, you're coding, you're building, you're testing, you're releasing, you're deploying, all in an automated way to allow you to perhaps just take a smaller chunk to begin with and then slowly grow it as you understand the processes, you understand your capabilities. Now, doing this modernization in place does have an awful lot of positives. It addresses the development skills challenge. Yes, we've tried to put more education in around COBOL and the mainframe and CICS, but it does allow you to perhaps pick from a larger pool of developers and start them with something like a little bit of Java modernization, working with maybe some of your expert COBOL programmers. But then as they start to become more of happy with working with that COBOL application, they'll start to be able to look more at that COBOL application and understand what it's doing and make changes to that native COBOL. It allows you to refactor code to support businesses and your business requirements and business agility. And it allows you to still expose those same applications as APIs. It allows those applications, regardless of the language they've been written in, to use the same CICS APIs for things like security and transactionality. And it allows an incremental rather than a big bang approach to modernization. Take a little bit, modernize it, rehost it, take another bit, go through the loop again. And each time you go through the loop, you're hardening your processes, you're tightening the processes, and you're making them more efficient. We're not for 1 second thinking that anyone could go, well, we're going to modernize this whole big chunk of COBOL, we're going to modernize it to Java, and we will do it perfectly the first time. That's just too risky. You could actually, it's better to take a small piece, run it through that loop, and then have a retrospective. What worked? What didn't? What was it about our DevOps processes that could be made better? How can we learn more? And this introduction of CI, CD, and DevOps onto a language which, for a lot of people, they believe is more suited to these types of approaches, allows you to understand more about that approach and how you could apply it to perhaps some more of your traditional CICS applications. But of course, it does have a downside. You are going to be writing net new code. You are going to be migrating code from one language to another or introducing new capabilities into CICS. So you are writing code, and that is going to take time. That is going to have a cost associated with it. But in doing so, like I said, you're going to be reiterating over these DevOps practices and tools and hardening them. So as you continue, that kind of cost should start to diminish as you're able to make changes and get them tested, integrated faster, with more control and higher quality. And often when we talk about CI/CD, we talk about it being done in a cloud native way with containers and Docker and Kubernetes. But actually, they all apply to Z. The core principles and practices apply to Z in the same way that they do to a cloud native world. I can still code my application in a choice of languages. And in version 5, we made huge advances with our Java support, our Node.js support, but we've also put core new capabilities into the base of CICS that support all of the languages that you can write a CICS application in. But you can take that application, you can code it, and then you can build it. And in version 5, we've done things with Spring Boot, Maven, Gradle plugins. So if you're writing your code in Java, now that can be deployed to a test CICS application in pretty much the same way that you'd expect it to be deployed to any Java application server. When it comes to testing, we can now use things like ZUnit and Virtual Test Platform to actually do unit testing of your core CICS applications as part of your build pipeline. You're not having to test everything end to end or do everything manually. You could actually run bona fide unit tests where we are stubbing out the entire CICS environment and just running that COBOL application with a simulated kind of mocked bubble around it, and allow you to run applications and test them in that stubbed environment as part of your build pipeline. Of course, that's not all the testing you're going to be doing. You're going to be using integration test tooling. So you're going to be running the application end to end. And you can use things like Galassa and other test tooling to do that. But Galassa is something that we're producing as an open source project to allow you to really accelerate your integration testing, to allow you to incorporate that style of testing into a DevOps pipeline for your traditional CICS applications. Then, of course, you're going to deploy your application. And CICS is still the best application server for running high security, high throughput transactional applications, regardless of the language that they're written in. We then provide you a whole set of DevOps tooling for more the ops side, where you can understand how your application is running in production. You can check the performance of it. But also now we're seeing more of these this tooling providing data in an open way, so it can be implemented into an ELK or Splunk stack using App Dynamics, so you can monitor the application in the same style, in the same way that you might monitor a public cloud application running elsewhere. And this infinity loop, I think I heard an offering manager talk about it as an infinity loop. Not as quite as interesting as the Infinity Saga for the Avenger fans, but this infinity loop allows you to iterate around this constantly working out what's the next thing we need to do, what's the next change we can make to our applications, what's the best language to write it in, how do we build it, test it, how do we deploy it, and then how do we monitor how well that's running. And as I said, in version 5.6 of CICS, which we made available on the 12th of June this year, is really the latest iteration in that version 5 story of making CICS the premier mixed language application server. And I'd just like to say, actually, that when we started this year, we obviously knew we had a GA date in mind. And it really was an entire team effort from the CICS team not just in Hersley, but across the world, to allow us to hit that date, even though we were all working remotely. The amount of work I saw the team do and the pulling together that we did to get that out of the door was really superb. And when we released that, of course, we made the main product available, but we also released the VUE and developer trial version of the product. So if you're not aware, Dev Trial 5.6 allows you to take a version of 5.6, install it into a dev test environment and start to play with some of the new capabilities. Maybe set up an environment where you can try out some of the JSdk capability, start using the Maven Gradle plugins, and start to experiment with some of the new capabilities we've offered to see where that might take your applications. One of the key things that we've been talking about throughout the whole of the version 5 capability is about co-location of applications. Previously, and perhaps previously to version 5, applications such as Java were often seen as something that ran in a different tier to your core CICS applications. Your core CICS applications were COBOL, PL1, and your more different, your newer applications written in Node or Java EE were written and deployed to a different tier. Now, as we're looking at a hybrid cloud architecture, and we're looking at network latency and where these applications are actually logically deployed, we need to consider, is that still the right thing to do? Does increases complexity? And as you're thinking about perhaps moving or splitting your application out across multiple tiers or multiple clouds, this becomes a more pertinent thing to be thinking about. So having that mixed language application capability within CICS allows you to consider to collapse those layers into one, into a physical, a single logical tier, where your COBOL, your Java, your PL1 applications can all run together in the same address space. And doing that co-location of those applications reduces the latency. In most cases, you're going from a physical network hop from one device to another to now a cross-memory call, which of course is going to be more efficient. But it also simplifies the overall deployment of the application, because you've now only got one address space that you need to manage, one address space you need to control, and also only one that you need to audit. So it gives you greater simplicity in your overall architecture, and it also gives you improvements in terms of latency and increased performance. And this is where the story about CICS as a mixed language application server really is important, because that same set of application, sorry, the phrase has slipped my mind, but the same set of core capabilities that CICS offers are the same regardless of language. COBOL, calling a Java application, executing a PL1 application, all within the same unit of work, with the same level of security, and being monitored within the same address space. And for those that really are still on the fence about Java, Java in CICS is no longer something that is new. It's been available in CICS for maybe over the past 15 years. It's a proven production-ready solution. Java in CICS does work. And we've got over 500 customers that are running Java Standard Edition applications under CICS, and 200 of those are now starting to, or are developing or running Java Enterprise applications in CICS using the embedded WebSphere Liberty platform server. And that number of customers is just growing. Not only is Java on CICS reliable, it also allows you to harness around 14 million Java developers who could start to work on these new applications and keep them thriving. You also can take advantage of zip offload for ZOS. So a lot of these applications are going to be mostly zip offloadable, which means that they're going to reduce from your your general purpose CPU count, and they'll just run on the zip where possible. And the support for Java EE applications We support Java 8 Enterprise Edition from CICS version 5.5, and we're looking at how we're going to go ahead and support later versions of Java as we move forward. But particularly in 5.6, we introduced further capabilities to our Java stack. And one of those key ones was in Spring Boot. So if you know what Spring Boot application is, it's basically the ability to write a Java class and with just a few annotations, deploy that application and develop that application without any web application server configuration. So it allows you to take the application and deploy it in a very quick, very easy manner. And Spring Boot takes care of all of the other considerations. And the great thing is that you can now take a Spring Boot application and in CICS 5.6, run it without any modifications. We've got some examples out in GitHub that can show you exactly how you do this, but it allows you to take a Spring Boot application that you may have been running in a different tier of your enterprise and co-locate it inside of CICS and take advantage of all the capabilities that we just spoke about. And like I said, it was introduced in CICS 5.6, but it's available in CICS 5.5, sorry, in CICS version 5.5 with that APAR applied. Secondly, our Node.js application support. So we now support the ability for you to write applications written in Node.js. And they are deployed as part of a bundle. So you can take a bundle that, they are deployed as part of a CICS bundle. So it's not a new deployment mechanism. It's taking use of the CICS bundle capability that we introduced all the way back in CICS version 4. We now support the Node.js SDK version 12. So this gives you a way of using the latest versions of Node.js and start to bring those applications online in CICS. And again, it's available in CICS 5.6, but has been backported to CICS version 5.5. Kind of looking just a little bit away from the just the core runtime support, we've also introduced a whole set of Java build tooling to allow you to deploy a Java application to CICS in the same way that you would do it if it was a Java application running anywhere else. So the way that you used to have to write a Java application in CICS was you had to use the CICS Explorer along with Eclipse for Java developers. And that was your route to writing a Java CICS application. You had to play with target platforms and select the right version of CICS. And then when you were done, you assembled it into a bundle and you then pushed that bundle onto ZOS. And you then had to go into CICS and discard the bundle, reinstall the bundle, and then you could test it. Yuck. It wasn't a great experience, especially if I was writing Java applications for, let's say, a WebSphere Liberty application. I was involved in a Z Hackathon event a couple of weeks ago, and I was working with some colleagues who wanted to set up a WebSphere Liberty application server to run a Java servlet that they were building. And the tooling was just there. They could write Maven or code Maven install, and that would go away. It would build their application, and it would then deploy it into a WebSphere Liberty application server, refresh the application, and boom, they were ready for testing. Took what, less than a minute, and from one command. And it was tooling that was natively understood by a Java developer. You can now do that even though your endpoint is CICS. So I can take my Java application, I can use either Maven or Gradle, I can use those methods of importing the JCICS API into my Java application. And when I'm ready, I just build and deploy my application in the same way that I would for any other Maven or Gradle app. And we provided plugins to those frameworks that allow you to then deploy that application into CICS, recycle the bundle, and get that application ready to work. So this means that I can go from writing some code, Command S, saving my code, running a command using Gradle or Maven, and have that application deployed into CICS, ready to go. I can test it, and then I can recycle. Now, these are things that we have designed for dev test purposes. We're not expecting this is how you deploy your application directly into a production environment, but the build technology could be the same. So this allows you to take those Java applications and build them as part of a CI/CD pipeline and get that asset ready for perhaps more manual deployment into an environment. And again, this is available, or it was introduced as part of CICS 5.6, but we've made it available all the way back to CICS version 5.2. So if you've got Java developers in your enterprise, this is really something that they should be getting involved in, because I've played with this and it really is, as a Java developer from university, it's a really cool piece of technology. But with all the cool stuff and the new flashy, shiny language support we've added, we've not neglected the core base of CICS. We are still release on release satisfying sets of customer requirements to improve the core capabilities of what makes CICS so important. So in CICS version 5.6, we've addressed over 50 customer requirements, and Jenny He later on today, I believe, is going to be taking you through all of the enhancements that we've added into Foundation over this last release. But we've got support for JWT tokens to allow you to understand the content of a JWT token and do multi-factor authentication. We've got new policy system rules so that CICS can start to understand the state of an application and respond accordingly. We've got a whole range of ZWIC improvements, so we can now collect ZWIC data and emit it. And we've enhanced a whole set of stuff. I'm not going to go into it. Jenny's going to go into this in far more depth than I could possibly. But it's important to note that with all of the enhancements we make to things like Node.js and Java, we are also enhancing the core capabilities that makes CICS what it is. Similarly, it's important to note that CICS is not an island. CICS is, well, at least since I've been involved in the product, and even more so as we start to look at the hybrid cloud architecture, it's going to be important that open tools, open technology, and open patterns of working can be applied to CICS in the same way they can be applied to other parts of your application. And so you're going to start to see a lot more of this coming from IBM. So things like using Ansible playbooks to automate things on IBM Z. And this is usable right now. So you can take an Ansible playbook and you can start to automate things on ZOS through the Ansible playbook. Now, if you've been doing things in automation on Z for a long, long time, you may be saying, well, why is this important? Well, because it's an open solution and it's had incredible traction within the distributed world, it's a tool that a lot of people know and understand, which means that you can get more leverage when you're sat in a meeting and someone says, oh, well, we're deploying this part of the application with Ansible. Oh, but of course, ZOS can't do Ansible because it's ZOS and it's the mainframe. Now we can start to say, well, hang on, we can do things with Ansible. What's our use case? What is it that we're trying to achieve? Because the base support is there. If there's something missing, we might be able to get that added. But we do understand what Ansible is. So we can share in those, we can join in those shared conversations. I remember a few years ago, I was doing a few demos and some kind of some few things that myself and a group of others had knocked up as part of a meeting with clients in the lab. And I showed something off and I had a client come to me and say, well, how are you doing that? I said, oh, well, it's just APIs, isn't it? What do you mean? Oh, well, I'm exposing my logic as APIs and I'm just getting someone else to just call those APIs. And he turned to me and said, thank you very much, because in our business, we've been talking about APIs and I just didn't know it was possible to do that kind of stuff on Z. Now I know that, I know I can be part of that conversation. And I think that's part of the problem is if you know you can be part of that conversation and we can have that shared conversation, then it means that the mainframe starts to become more relevant in those conversations. Once we've developed and built our application, of course, we're going to want to test it. We spoke a little bit about ZUnit. I'd like to spend a little bit of time talking about Galassa. So Galassa is an open source deep integration test framework based upon the same technology that we've used in CICS and other parts of IBM for over the past decade, released as an open source project, allowing you to write tests, automate your testing, and to execute that testing at enterprise levels of scale. And James Davis and myself are going to be doing a session on the DevOps track. So not to steal Rob's audience, but there will be an excellent session from James and myself in another session on the DevOps track next week, talking about Galasa and the capabilities that are available there. Now, a lot of the stuff that we've been talking about hasn't just been new that's only in version 5.6. Like I said, this is an extension of the story that we've had all across the version 5 timeframe. And we're starting to see customers resonate with that story as they've started to take some of the capabilities and build things that they can now, so build new capabilities within their applications. And one example is Bank Data, who wanted to use Java as a language to modernize some of their CICS applications. And they built a whole set of new applications, and they did some modernization of existing applications with Java. They created new JVM servers in which to host those applications within CICS, and they wrote the logic to allow COBOL to call those Java applications and for Java to call the COBOL. And they've now got a whole DevOps pipeline process to deploy those Java applications. So they can now write an application in Java, and with a click of a button, each time they make a change, it automatically goes through a build, test, deploy phase to understand how good that change was. Does it work? Are there any bugs in it? But that whole end-to-end pipeline has been developed on open software, things like Gradle, Artifactory, Git, and Jenkins. And the net result has been they've significantly improved the amount of time it takes to make a change. The kind of big kind of sell story of the cloud is you have an idea in the morning, you develop it through lunch, and by the evening, you've got it deployed. Well, Bank Data can now start to live a little bit of that through their Java applications. It used to take 15 minutes to make a change to the source code. It now takes 1. So that's a massive improvement for them. And they're now that benefit that they're seeing means that they can now call some of their COBOL applications through this Java layer that they've built from anywhere in their enterprise. And they're starting to experience this wider pool of developers that they can pull from to further grow their capability. So it's been a really, really good success story for them by taking some of the core componentry that we've delivered in version 5 of CICS, deploying it, and actually getting results from that work. And quickly touch about some of the cloud runtimes and existing applications. And this is really just touch quickly on CICS TX running on the cloud. So CICS TX is now available as a Docker container, which means that it's not obviously a direct replacement for CICS, because it only supports a subset of the CICS APIs and doesn't have the same levels of scalability and data IO throughput as CICS. But it does allow you, if you've got CICS TX applications that are running, perhaps that are then linking to your main CICS application, that subset of applications can now be run on the cloud through CICS TX deployed as a Docker container. And it's integrated with Kubernetes to allow you to provide that level of container orchestration, either using Kubernetes or Red Hat OpenShift. So this kind of way of integrating applications into the cloud and providing capabilities through allowing you to deploy CICS TX as a Docker container is a very interesting discussion point. So in summary, because I've only got a few minutes left, over version 5, CICS TS has evolved to become the world's most powerful mixed language application server, supporting a range of applications or written in mixed languages with a shared programming context, allowing you to understand or to monitor and control the transactionality, the security, and the management of your applications, regardless of the language that they're written in. And 5.6 is the latest evolution of that line of thought. Not only have we hardened the base core foundation of CICS to support things like JSON web tokens and new policies and web services enhancements, But we've also further finessed our Java EE capabilities to allow you to do things like deploy Spring Boot applications natively into the CICS runtime. We've increased our Node.js support to support Node.js version 12. But we've also provided a whole wealth of build tooling, test tooling to allow you to deploy and build those applications as not quite cloud native, but definitely along those lines to allow you to deploy those applications as part of a CI/CD process and pipeline. And as I said, if you're interested, I'm sure you all are talking about the foundation, a point around the CICS and Java support that we've already discussed. I do want to point this. We've got a whole bunch of CICS resources that are useful to you. So coming to these conferences, while it's great to chat with our customers and clients and hear your views, doing that virtually until we can get back together in a room and we can have those types of discussions. But until that day, there's a whole wealth of resources that you can use to build your CICS capability. And there's a few here that I'd like to pull up on. The first is the CICS Developer Center. Here, we've started to put onto GitHub a whole load of source material and samples and examples to allow you to understand or to build new capabilities in CICS. So I spoke about the Spring Boot capabilities that we've added. You can now take those Spring Boot applications, and we've got a sample in GitHub which you can fork and download and use to see how that might work for your applications. But we've also got a wealth of CICS Redbook courses. We've got an Introduction to CICS course and 3 Java on CICS courses. Now, these are available at no cost. They're done at your own time, and they're really useful, perhaps taking a new starter through CICS to get them to understand what the core CICS capabilities are. But also the Java in CICS courses allow you to understand all of our Java capability and how you might take advantage of that. We've also got the Ibm Z Community. So this is kind of a new hub where we're trying to pull multiple different threads of content together into one place, and it's themed around your role. So you can join it as a developer, programmer, and we'll give you the right types of content for you to engage with. You can also speak with other people, other users, and ask questions and have that level of communication. Another quick talk about the CICS Developer Center. And finally, just to talk about Ibm Z Trial. A lot of the new capabilities that we're introducing, things like Node.js, Spring Boot, are often things that would take a little bit of effort on your behalf to actually get up and running and doing. So let's take Node.js, for example. You need to install Node. You need to have the latest level of CICS that supports it. You may need some extra tooling. What application are you going to port? What you might want is a pre-potted example with everything you need in a box that you can just use at your own time for free and understand what that technology does. And that's what Z Trial provides. It allows you at no charge and in a on-demand environment that we provision for you, a way of going through a sequence of instructions, a set of instructions to go through a scenario or an example of how to build an application or to solve a problem or to deploy an application. And it requires no setup or install on your laptop or on your mainframe. It's all in a pre-provisioned, cloud provisioned box. And these hands-on tutorials really allow you to understand exactly how to get it going with a piece of CICS capability. So, thank you very much for your time. I'm sorry this is virtual and we're not meeting face to face, but I hope in this session I've helped you to understand that even though we're moving to this chapter 2 of cloud and cloud migration, that CICS as ever is remaining relevant, and your applications that running on CICS have got a rich future ahead of them as they integrate with the rest of that hybrid cloud architecture. Rob, back to you.
Thank you very much, Will. It's been good having you do our first session, and you've coped admirably. A lot of stuff there for me to take in. and a lot of stuff that kind of resonates with what we're looking at with our customers and things at the moment, particularly interfaces, exposing CICS applications. Jenny's coming along at 3 o'clock, and tomorrow, just a bit of a plug, you mentioned Java. We've recently done a POC at my place, porting a Spring Boot application from Pivotal Cloud Foundry to CICS. And at the end of Phil's presentation tomorrow, I'll be going into a custom experience on that if anyone's interested. Results were very positive, sparkling, in fact. That's about it from me. Please give feedback. Hoping that we'll be able to meet more people with these virtual sessions in years to come, but I need your feedback to say if they're any good or not. And thank you very much, Will, and good luck with the rest of your presentations this week. And good luck to everybody else on your sessions. Hope all goes well for you.
Cheers, Rob. Thank you.
Cheers, everyone.